Hello folks, welcome back. So after studying the symmetric encryption, now it's time to take a look into asymmetric encryption. Now as we studied symmetric, again I'm saying symmetric stands for similar, but asymmetric is something that is not similar, which means it is different, right? So here we are talking about a key which is different between the sender and the receiver, right? And whenever we talk about asymmetric encryption, you will always remember that you're talking about two keys. We call it the public and the private key pair. Now here we are taking a quick example where Bob has to send a message to Alice. Now Bob sends a message called hello Alice. Now we know that we need to encrypt it using a key. As I said, there is a combination or there is a key pair. Let's say Bob sends the message using Alice's public key. Guys, always remember that if I am encrypting a message using Alice's public key, then there is no key in the world except Alice's private key that can be used to decrypt this message, right? So if you see, when this garbled characters or this garbled message comes over to Alice, Alice needs to apply her private key to get the message back, right? So always remember these key pairs, as they're called pairs, right? They are peers to each other. You can even say they are peers, they're companions, right? So they always work in pairs. If you're doing something with a public key, you do the other part with the private key. Or if you do first part with the private key, you do the second part with the public key, right? And we will look at all these different scenarios, but let's try and understand the theoretical part. So asymmetric encryption is a type of encryption that uses two keys, public key, private key. Now let's try and understand that part, right? As the name suggests, public key. Public means something that is available to the whole world, right? If I have my key pair, if I'm generating my public private key pair, then I can distribute this public key to the whole world. Always remember, I will simply distribute it, right? But private key is something that is close to my heart. I always say private key is close to my heart. Never share your private key. Private key is something that stays with you, right? So the public key is freely distributed while the private key is kept secret. Another key important here thing is secret. Only you should know your private key. Never share, never send, never distribute your private key. Quite important. We studied as well when we were learning the history of cryptography. Asymmetric encryption is also known as public key cryptography. Whenever somebody says public key cryptography, you need to understand we are talking about the asymmetric encryption, right? It allows secure communication without the need for a shared secret key, right? This is what points to symmetric, which we are not doing right now, right? So what it says is it allows secure communication. If you see hello Alice message is being sent to from Bob to Alice, it is sent in an encrypted manner and then getting decrypted, but the key is not being shared. If you see, this key is different from this key. The key that has been used to encrypt the message is different from the key that has been used to decrypt the message. And that is what is the key takeaway, guys, that it allows secure communication, but you don't use a shared key. Shared key is always used in symmetric encryption. So asymmetric encryption is based on mathematical problems that are difficult to solve, and such as discrete logarithmic problems and factorization of large numbers. And we will study about this. Don't worry if it sounds confusing. So what it says is, and as we already studied, any encryption, decryption that we are doing is always based on a mathematical algorithm. Or you can also say it's basically something like a mathematical formula. It's not only a formula, but a collection of formulas. And on top of it, when we talk about keys, we always say, and most of the time we are talking about large prime numbers that we are talking about when we are applying these keys, or when we are creating these public-private key pairs, right? So in the very early videos, we studied the CIA triad, right? You might remember the CIA triad. So the asymmetric encryption helps us to address the confidentiality, integrity, authentication piece of it. And on top of it, you can get non-repudiation. What is non-repudiation? It is a situation where an author cannot dispute the validity of a contract, and it's done through a concept of digital signatures. Again, we will see in the forthcoming videos. But all I want to say is it's so important, and there are so many advantages of asymmetric encryption. Like, it can easily answer all problems which are given by CIA triad, which are confidentiality, integrity, authentication. But now the thing is, if a certain thing has got advantages in life, there might be some caveats or some disadvantages. Now, if you can remember, we said that symmetric encryption was very fast. It uses less computation power. Now that becomes the disadvantage for asymmetric encryption, because asymmetric encryption is considered to be slower. Why it is slower? Because you need to work. So there's a lot of CPU computational power needed, because you need to work on a lot of mathematical operations, right? That's why it is considered to be slower. And you're not using the same key that has been used to encrypt and to decrypt. So it's always based on complex mathematical operations. And if you talk about use cases, asymmetric encryption has been used in various applications where you need to send secure messages like SSL, secure socket layer, TLS, transport layer security. PGP is the pretty good privacy, we call it. Then SMIME, which is an extension to the simple mail transfer protocol, or the SMTP. So all I want to say is there are a lot of, say, use cases for asymmetric encryption as well. But as we studied in symmetric encryption, they were prone to some brute force attacks. Similar way, the asymmetric encryption are also a bit vulnerable to the brute force attacks. You can also have some side channel attacks and some quantum attacks. So quantum is a pretty new concept, I would say, where quantum computing is coming, which is using the computational power of the computers to break these encryption algorithms, or to break these encrypted messages, right? And as we studied in symmetric encryption, because symmetric encryption has certain advantages and disadvantages, it means that it needs to be used in combination with different other algorithms. So that's why in normal computational or normal, say, when we are sharing messages on the internet, we always used a combination of symmetric plus asymmetric. So symmetric plus asymmetric is always used. That's why we always need to study symmetric encryption, what it is, what are advantages and disadvantages. Same way we need to understand asymmetric. But if we combine these two, then we get a powerful solution, which is kind of a hybrid encryption, which we use in our day-to-day, I would say, secure communication. So this is all about asymmetric encryption. In the next video, we'll take a look at kind of an example where Joy needs to speak to Aileen and needs to send the hello message, how it works. Thanks for watching.